general relativity, step by step. We've got this nice expression for dust, or for the stress energy tensor for the dust, which is rho 0, and then everything else in the whole expression is 0, so 15 zeros here. And that's dust. What I'm going to do now is talk about the stress energy tensor for a fluid, actually a perfect fluid. I'm going to talk about this. So I'm going to take my stress energy tensor, which I'm just going to write as 16 dots here in this arrangement. Bonk, 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 bonk. Is that right? Yep. And I'm just going to focus on these three here. And I have mentioned this before, but I'm going to talk about it in more detail now. This in classical mechanics. These 9 numbers here, 3 by 3 matrix. This corresponds to the stress tensor in classical mechanics. Which I'm going to call S. And that's the matrix S, and IJ is row I and column J, where I and J are 1, 2, 3. Because I'm not considering the fourth component, I'm just considering the 3 stress here. The meaning of Sij is equal to the... There's no good word for this. I'm going to put flux in quotes, or transfer of I momentum, where I equals 1, 2, 3, so that corresponds to x, y, z, I momentum, in the j direction. And when I say in the j direction, it might have been better to say perpendicular to. In fact, I will say that. Perpendicular to the j direction. So the way to think about that is, if I want to work out what the meaning of S12 is, then that is the flux of one momentum, or x momentum, I guess, in the y direction. In the 2 direction, I guess. Oops. In the 2 direction. So if I draw a little control volume here, and here's one here, I'm exerting, there's box A and box B. These are boxes of little things, it might be rocks or something, and that is the 1 direction and that's the 2 direction. We can imagine this one moving in this direction, and there's a frictional force transmitted through this plane here which makes box B tend to move. So in this situation here, if it's actually moving, there's a frictional force set up. This is the way I think about it. There's a frictional force set up which causes box A to exert a force on box B. So I would say S, which way around have I got it? 1, 2 is not equal to 0 because of a frictional transfer across this interface here. This interface, of course, being characterized, I guess I could draw it in 3 dimensions. Well, my drawing skills aren't very good, but this surface here is perpendicular to the 2 direction. And it can transport momentum in this momentum in this sense here across that surface there. So in this situation, S12 would be not equal to 0. S11, however, is, if I can draw this control volume again, this is something a little bit more straightforward to understand. Maybe I should have started with this. Okay, so I'm talking about momentum transfer of this momentum in this sense here going in that direction through that plane there. And so, of course, S11 corresponds to the pressure in that direction. And, of course, S11 equals S22 equals S33 equals P for a perfect fluid. I have said this before, but I didn't emphasize it. Okay, so, and also, Sij equals 0 if I is not equal j for a fluid. Because a fluid doesn't have any, or certainly a inviscid fluid, doesn't have any of this business of transferring momentum in that direction across that that interface there. So, so for a general fluid, or not for a general fluid, for a perfect fluid, what have we got? We've got Tij equals, still got a density, and let's just say that we're evaluating its stress energy tensor in its rest frame. We've got zeros off, we've got something there, something there, something there as well. We've got zeros here, 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 and here, and here for the off-diagonal elements of the stress tensor, but here, here, and here we've got the pressure, and for a perfect fluid there's just a single number. Actually, I'm going to call it P0. And this is the stress energy tensor for a perfect fluid. Stress energy tensor T alpha beta for a perfect fluid in its rest frame. Which is quite a nice expression. So you see, before we had zero pressures, and so that meant that we've got zero terms on this diagonal here. We've got rho 0, P, 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 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and that's equal to T alpha beta. Stress energy tensor for a perfect fluid. Stop.